Bismillahirrahmanirrahim. In today's topic, we'll discuss about the distance measurement. The distance measurement and how to use different methods depends upon how much accuracy you require. The more sophisticated equipment you require, the more accurate it will be. But it depends upon the situation in which and the application of that distance to your work. Sometimes accuracy is not important, so then we go for some older technologies. And if accuracy is very important, then we have no option but to go for modern technology. Let's have a quick look of the older technologies. If you measure the distance with pacing, then you will have an error of 1 in 50. If you use optical rangefinder, the same error. Odometers is more accurate than pacing an optical finder, 1 to 200. Tachyometer, 1 to 500. Substance bar, 1 is to 3000. Tapes, 1 is to 10,000. And EDM, that is 2 plus 2 part per million. So this is how you know which method is selected for the particular application of your distance measurement. Let's wait for a full slideshow. Now, whatever method you use, you applied two principles of measuring distance. It, we all know that to form a line, we need to take at least 2 points. The second principle is the shortest distance between 2 points is a straight line. So even if the ground is not as you desired, you always take the shortest distance. In the field of surveying, the distance has two uses. The common use is to measure the displacement between two or more points, like this. And then distance can also be used to define the dimensions of an object, like here. Now, what method is appropriate? How we select the best method? For that, we have to look, or we need to know how, what factors influence our distance measuring method. Environment, use of the data, equipment available, expertise of individuals. It can be a personal preference, then topography, the client specification, the regulations, the standard practice. So these sometimes you have many instruments and you have a latest equipment, but the person in charge doesn't know how to use it. Sometimes you have a mountainous topography and the accessibility is difficult, then obviously you go for latest technology. Then if the client requires we want measurement, say from total station, then even though you have an expertise on some other instrument, you have to follow the specifications. There are regulations that some instrument cannot be used. Then obviously like drone nowadays, even though drone is very common, but there are places that has geographic restrictions on you, like an airport. You cannot fly a drone on the airport because it may intersect with the aircraft operations. And then, last but not least, what instrument people are generally use is common is what we are going to use, even though we have an expertise of the individuals in some other area of measurement. And this is the defining line where to use the data. Let's go quickly. What are the devices we use for measuring distances? Pacing, odometer, chaining, stadia, electronic distance measurement, EDM, and GPS, global positioning system. Let's go with pacing. Pacing consists of counting the number of steps or paces in a required distance. The length of an individual pace must be determined first. It also depends on the person because it's sometimes a person may be of a 5 feet height, a person may be of 6 feet height. So then the pace of the steps, the distance in one pace may be different from different people. So in order to calibrate it, what we do, we walk the natural steps back and forth overall level course for at least 100 meter or you say 328 feet and divide the known distance by average number of steps. For short distances, the length of each pace is needed, but the number of steps taken per 30 meter is desirable for checking long lines. Pacing is a very common method um, for knowing the estimates of the length when you don't have any instrument, and those you know plays cricket, they know how you measured the pitch distance by steps. So usually it's to apply this pacing technique in in your play field for cricket or setting the goal post um, in the ground like this. It's a very simple technology, no technology actually, and you don't need specialized equipment. All you need to do is to keep the check on the length you covered in one pace. Disadvantage, if you have to climb on a mountain, then obviously the topography will be affected. And then obviously you require a practice to take a consistent pace. So one pace is the distance between from one toe to another toe of your leg, and obviously that there should be a person who is able to walk 100 meter. No, not that person who stops every now and then takes 200 meter. Then this will be of no use. It can measure slope distance as well. So the accuracy is very less, 2%. Then there is a odometer. One of the simplest way is the odometer present in your car. Yeah, this is odometer. So convert, and then there is a unicycle thing. Uh, this is an handle, and then this is a measurement box that actually records the revolution. This wheel has taken into traversing a distance. So, sorry. Given surface densities, convert the number of revolutions of a known wheel of a known circumference. Give surface densities which should be corrected to horizontal if the ground slopes severe. Then there is an optical range finder in which you use this instrument. There's a mirror A here and there is a mirror B here. You devise the distance and you focus on this point. This R is known to you, and this D distance between two line, the two ends of this optical is always known, so you can find the distance, this distance, or you can find the distance. All you have to do is to measure from this side your target, measure from this side your target. Ultimately, you will get the angle, and you know this distance. So when you can always find this distance by using this r is equal to d tangent theta. Another method is known as chaining. It's a traditional method of measuring distances, usually 30-meter length or 100 feet, let's say. Two common types: add, cut, available in steel and cloth. Some people may confuse chaining with taping. Actually, both are same, but the instruments are different. Nowadays, 99% of the time you use tapes that can be steel or synthetic lining cloth that are being used. This also parts the chaining, and then in the later part of the lecture, I will tell you what. Then there are other fixed length uh, links chain. It's actual chain actually. It's of steel that are also used to measure distance, but nowadays it's not very common and it is very rarely used, especially in developing countries. What are the advantages? High precision, 0.0003 meter accuracy can be used to measure horizontal distances. Disadvantage, multiple people you require. You must have a clear travelable route. High precision requires temperature and tension correction. 0.1% error is expected by using taping. Other type of chaining is actually the chain that has got links, and the most common type of chain is a Gunter chain, 66 feet long, comprised of 100 links. And if you count 80 chain, there is 1 mile. And if there are 10 square chain, that is 1 acre. And if you have 4 rod, then it is up one chain. And at every chain, these are marker. This marker at every 10 feet, you will find this marker of this has got one nose. It is at 10 and 90. If you have two nose, then it's 20. Three nose, 30, or it's a triangle. Then the 4 nose, the 4 points, then it's 40 or 60, and it's 50, the round. So these links are attached at these distances. Then there are other chains as well, engineer's chains, 100 foot long, 100 links, more convenient in leveling operation because of leveling staff graduated in fit, more accurate in long line measurement because of its greater length. So, in every case, there is always an equivalent of a fit unit, and that is a meter chain. Obviously, meter its length, 10, 20, 25 meters are commonly used. It has also got 100 links, and the brass tags, as I've shown in the previous chain, they are also attached at every 2 meter. So in 10 meter, you will have at least 4 brass tags. So you can say it's either a taping procedure when you measure in uh, with a tape, or it can be a chaining procedure. But let's stick this word to taping because I already mentioned that chaining is not being used nowadays. For that, for taping procedures, we have to set up ranging rods between points A and B. Uh, at point A, we set 0, and then we unwound the tape towards B. A third range rod is the rod is also used at C. It's a middle distance, and this for straightening the taping procedure. And you read the red rod at C as well. So once you use it, you mark a pin or you insert some peg at that point, and then you move on further. So that's for the next way, tape move from point A and 0 set at C and so on. So let's understand. For instance, you have a distance of say 320 feet. So one point at 0 point at the start, and the second point is you know at 320 feet. The tape is usually 100. So for instance, we have to use the tape of 100 feet. That's very common for distance, measuring distance. Now we align from A to B, and we start to move towards B in the line of the rod B. When your 100 feet is complete, we insert a peg, or we say first we insert a rod C, and standing at point A and looking at B, we try to insert C in such a manner to in such a manner that this both point C is within A and B. Then you just hold the tape tight, read the rod at C, and insert a pin or peg. For next way, tape move from A and 0 set at C, and so on. But there is another way I can tell you, maybe not here. Whenever you set the rod at A and set the rod at C, what you need to do is to take a string that obviously may be more than the distance you measured. For instance, here you can have a 350 feet long string, and On that, you tie the knots or you tie the strings between point A and B, and so that you don't need to correct the alignment. Now you are in straight line, and you have to tie the string very tight, and now with the help of the string, you are never worried you are going somewhere else. You move with the tape, and whenever you reach 100 feet below the string or with the string, you hold your rod C, or just simply peg uh, peg the ground, and that's it. And we move on along the string. So these are the accessories. These are ranging posts, and sometimes, and many times, you need plumb box so that uneven ground uh, uh, can be held. The point should be uh, marked with the with a set vertical rod, and these are the pins, or not only pins, and but there are sometimes, and many times there are pegs as well. That can be inserted directly to the ground with the help of hammer. So there are 6 steps of taping. Lining in, you have to adopt the shortest distance between 2 points. Always apply tension. For tension, the 0 point is well anchored, and the other, the head which you are moving, and whenever you have an approximate whole chain or tape, you apply the tension so that this tape is straight, and you have a correct distance. The plumbing, uh, in order to measure the horizontal distance, we use that plumb bob. We mark the tape length by pins to obtain total length, and at the end you count pins, how many pins you have. So you don't have to remember. Normally, if you have you know peg of say 10 pins, so whatever is left is the distance you have measured. So you peg the pin normally at each tape length. So say instance you have pegged five pins, that actually this is 500 feet, and the last you need to measure how much it is. Let's say if you are measuring say 40 feet, so the last pin and the fifth pin have a distance of 40 feet. So that point you measure. So you always know. It's always easy to remember by you know using chain pins, or I say keep on saying that peg uh, along the alignment of your chainage. Another thing, obviously, when you don't know how to read the tape, the whole process is infertile. So the graduated tape must be read correctly. Recording the distance, this always the objective of using the chains. So the total distance length may be reported and recorded correctly. Process in chain surveying, again, we just keep on chain is the continuous distance of measurement. It doesn't mean we are using those metallic chain. We are actually measuring. We are actually measuring with the tape. But chain, sometimes people get confused. When we say chain, they think we are using only metric chain, either Coulter chain or engineer chain, metric chain, but actually we are not. Chaining is the process of measuring the uh, distances between the 2 points, and the instrument can be a chain or it can be a tape. So, with this clarification, let's move ahead. How you range and measure the line, the level ground, there is nothing good at this in ideal condition. Then there's a uniform sloping ground, and last but not least, it's an uneven ground. On a level ground, like I said, This I already explained to you. Insert at A, insert at B. I always recommend tie those rods and take the subsequent measurement. A1 means 100 feet, 200, 300, at 800 feet, and the rest of the distance at point B. Just keep on pegging rods C first and then pegging the rod or the pins inside the ground. There is a terminology that's stationary. It's a very common terminology, and as always, students get always confused with this plus 0 plus 0, 0, 2 plus 50, 4 plus 96, 5 plus 43. What's this? Actually, if you remove this plus, then what's this is? This is triple zero, this is 250, this is 496, 543.12. So, in another word, why we use 2, 4, or 5? It's very simple. 2 means you already have full tape, 2 full tape length, that's 200, and then you have the remaining tape that was not fully utilized, even only 50 feet is being utilized. So that means 2 full tape and 50 feet remaining till this point. Okay, when we reach this point, we have completed 4 uh, tape length, that is 400 feet, and the last step could not complete 100, actually it complete 96, that's 496. And last but not least, at this point, you have completed 5 chain, 5 tapes, 5 full tapes means 500, and then 43.12 is the remaining distance. In other words, this removing the plus will give you the actual distance 250 feet, 496 feet, and 543.12 feet. You must be wondering, sometimes you see these, there are plus and there are um, three distances, 3 units. So this, if you have 3 units after plus, then it's meter, and this is kilometer. So maybe you have taken 1 kilometer and 250 millimeter if you have got 3 digits after this point. So if you have 3 digit after plus, that you are measuring in meters unit, and before zero it is actually kilometer, after zero it is millimeter. But if you have 2 digits like that is shown, then it is fits, hundreds of fits. So ranging and measurement of lines, obviously this I have told you a little earlier, so I don't want to repeat this once again. So here it's very simple, this is what I was talking about, and that it works on smooth ground or uniform slope surfaces. 4 tape and 1 short distance. So this may be 4 plus 20, maybe 4 plus 30, maybe 4 plus 10. Then ranging and measurement of lines. Uh, for that, uh, well, if it is for uniformly sloping ground, we use clinometers and Abney levels, and for an uneven ground, we have some other method. Actually, the clinometers and Abney levels, they are handheld instruments, uh, very old instruments, and they help you in measuring the angles of the lines. So when you go to lab, please they have a look at it. Now, for instance, this is the uneven ground you have to measure. How you are going to measure this uneven ground or even this ground? And then obviously you always, when you are measuring distance, you always want to measure it as accurately as it is possible for your given instrument. So what you do, you raise uh, the point A, maybe by using a tripod, and then you measure it in this manner, stretching the tape, and you can measure like this. Sag curve measure is not common nowadays, and it is only restricted to steep tape only. Stretch the tape as it is, and you know the distance. So this is where you have one end, you have measured the tape 100. So this we call tape supported at ends only, and sometimes if it is a level ground, you put the ground tape on the ground, so it is supported throughout. So what happens? Actually, you have to measure it along the B line, but since uh, because of some reason you are not able to fully stretch the tape, you have to apply this correction to the tape, where W is the weight of the tape length, L is the length of the support, because here it is 100. But sometimes what happens is that if you have 120 feet length, so one segment LS can be different. Then 24 is the coefficient and P is the pull applied, that can also be measured to stretch the tape. Now for a sloping ground like this, what you do, you take this measurement and you always, with the help of the instrument, you always know the angle, and there you can find the distance using these relation, where L is always known to you, D is L sine alpha, so this is the vertical distance, and H is SL cos alpha. To be very precise, H is, by using Pythagoras theorem, H is L minus D square upon 2L, where H is the horizontal distance between 2 points, L is the slope length separating them, and altitude angle from horizontal, usually obtained with an apnea level and clinometer. These are the hand devices for measuring angles of inclination. So if the difference in elevation between point D and the ends of the tape is measured, and this can also be done by using a leveling technique that is already being taught to by the other teacher in this course. Now, how you measure uneven ground is like this. We go from measurement from downhill. So if you have to measure the distance between these 2 points, you are not going to start from here. You always start from sloping down. So for instance, you start here and you go full tape length, can be 30 meter, and you have to keep the tape horizontal and draw a plumb bob from this point and insert a peg here. This is one tape. Then what you do is start from this point and keep the tape horizontal and uh, drop the plumb bob here. Actually, plumb is always perpendicular to your earth. So it's always, whenever you drop a plumb, you can always find a verticality, and you start the peg, and then in three segment or say 60-meter horizontal, you can do it in uh, using tape by and plumb bob this manner, and always you tape towards the down rate, not the up like this. We have measured it, and now you have made this is horizontal, and from that point, the end point, the person is dropping the plumb bob. You can see the plumb bob here, and wherever the plumb drops, a person will uh, insert a peg here. So let's solve this examples uh, for sloping ground. For the following data, compute the horizontal distance for recorded slope distance AB. Uh, so AB is actually the line along the slope is 385.29. The slope angle, as we have determined, 6 degree 3 minute 26 seconds. So since H is equal to say AB cos theta, so 383.14 meter. So actual, and similarly for difference in elevation, you always apply this formula. If this AB is known to you and the difference in the elevation between point A to B is known to you, you can always use Pythagoras theorem to come up with this distance, true horizontal distance. There are always correction required in taping. So once a line is measured, it is necessary to convert the measured length into a horizontal length, and series corrections have to be applied, and five possible ways to be considered: error in step length, slope, tension, temperature, and sag. So once you measured the tape, measured the length, this is not final, and you have to apply correction. And once the correction is added or subtracted, then you will have a true distance. So what type of correction sometimes depends on what type of tape you have used. So for synthetic tape, only RNS tape length and slope correction will be applied, and this the accuracy of 1 is to 1000. So if you use the steel tape, only RNS tape length and slope corrections are considered. The best possible accuracy can be obtained in range 1 to 5000. Now, if you also add tension and temperature, then your accuracy increased 1 in 20,000. So for instance, if you measured 20,000 say millimeter, uh, then the error may be 1 millimeter. This is how you can read those 1 is to 20,000 or 1 is to 10,000. Sag only applies if the tape is supported only the ends, uh, and it may not be required all the time. So what is a RNS tape length? Tape has always have a nominal length under certain conditions, and the tape stretches with time. So standardization need to be carried out frequently by using reference tape or baseline. Uh, in this formulation, you can see this is a correction. C stands for correction. Small l means correction in tape length. LM stands for the measured length. whatever measured length you have measured at the end of a day. This is the standardization tape length. Maybe uh, this tape may be of 100 feet, maybe of 30 meter. And LM is the actual tape of the length that is now present. I mean that if there may be a tape, maybe 99.94 uh, feet, then this is a nominal length, assumed tape length. So this is the tape used when comparing to standard tape. The tape used indeed has a length. This is standard tape length 30, and this is the extended tape length. This can be minus as well. So this is delta L. For every 30-meter measurement, the small longitude amount should be added for correction. Then the slope. This slope can be determined from this formula, the measured length, this is the angle you know, and this is the length along the ground. So this and this is change horizontal, or actually it's vertical. So angles may be measured by theodolite or clinometer, as I've said, or even a total station nowadays. Actually, total station give you the correct length by itself. It's a built-in mechanism there. Then for tape correction, for tension correction, we use this formula. P is the tension you applied. P is the standardized tension. LM is the length measurement. E is the modulus of elasticity of the tape material. For steel, it is different. For steel, you can take this at um, 200,000 Newton per millimeter square. It can be, it may be 29 million psi in the other unit, and A is the cross section area. Uh, then there is a temperature correction, because most material expands and contract with tape change, and this affects tape distances. If a tape has a stretch due to heat, it will read shorter than it would at its normal. Alpha is the coefficient of linear expansion, and T is the temperature change. Tv is the temperature at the time of the measurement, and this is how you use this correction of tape measurement. So we can always look like this. This is another way of expressing the previous equation I've discussed. The length of the tape, it can be Lm. Alpha is the coefficient of thermal expansion. In, in centigrade, it is 1.7 into 10 power minus 5, and it's 9.5 10 power minus 6 per degree Fahrenheit tape standardized temperature. The TS actually is the tape uh, at which, when the tape was manufactured, it was standard. It was actually manufactured at that temperature. Now let's solve an example in which you know how to apply those corrections. So determine the correction for a steel tape when used to measure a distance of 250 meter, when the air temperature was 100 Fahrenheit and the standardized temperature is 72 degree Fahrenheit. Very simple. 100 minus 72, 9.5 into 10 power minus 6 alpha, and L is 250. So this is a tape correction. Then there is a sag correction. Here you will see this uh, complex equation, and sag correction is always negative because you are measuring more length as it is required. So that's why it's negative. If you have a full stretch, then this distance actually measuring in along the curve, and you always know measuring along the curve, this curve has more distance as compared to straight point. So that's why whatever you have measured is more, and whenever you measured more, you have to subtract from the actual distance. So W is the tape length, tape weight of tape per unit length. L is the length measurement. Theta is the angle. If the angle of slope is 1 or angle is not given or 0, P is the tension applied to the end. 24 is the coefficient. So that's come to Sag Correction. Now, what are the errors? Source, tape length L, systematic or random. This is point. There are two types of error. One error that can be corrected if it is a standard error. If it is a random error, that may not be corrected because you never know where actually it has happened. Now, what are the standards? Tape length, you have 0.01 feet is the least count. Temperature is 15 degrees Fahrenheit. This is the temperature at which the tape is manufactured. The standard pull is 15 pound. Then the sag 0.6 feet at the center for 100 feet tape length. This is how your distance vary. Alignment 1.4 feet at one end of 100 feet. This is systematic error, and as I say, systematic error can be corrected. Tape knot level, systematic plumbing. This may be a random error. Sometimes you plumb well, and sometimes you don't because of some other reasons. So these are random error, and at the end of it, you cannot apply correction to random error. You can only apply it to systematic errors. So this is the problem. A 30-meter steel tape is standardized at 20 degrees centigrade and supported throughout under tension of 5.45 kg, was found to be 30.012 meter long. The tape, actually I got confused. Actually 30 point, the length is what you measured, and the 30-meter is a nominal length. You have always supposed to be a 30-meter length. So that LM that we were discussing actually is the tape length of the tape that is supposed to be there. The tape had a cross-sectional area of 0.05 centimeters square and a weight of 0.0396 kg per meter. The tape was held horizontal, supported at ends with a constant tension of 9.09 kg to measure a line from A to B in 3 segments. The data listed in the following table were recorded. Apply corrections for the tape length, temperature, pull, and sag to determine the correct length of the tie. So actually from A to B, the distance measured is 81.5 feet. And from A to 1, the first peg obviously 30 meter, temperature about 40, 1 to 2, 15, and 2 to B 16. So you have to apply correction in segments and then you accumulate them to add a total correction in the end. So let's do it. So just jot down what you have. Standard tape length 30 meters, standard temperature 20 degrees centigrade, standard pull 5.45 kg, cross-sectional area 0.050, weight 0.0396 kg per meter, incorrect tape length 30.014, applied pull 9.09 kg. And these are from your data and some standard values. And there are some known values like coefficient of thermal dispersion and the modulus of elasticity of the tape, 2 million kilogram per centimeter square. So for correction of the length, we accumulate all the length. You have actually so 30 plus 30 plus 21.5, incorrect length of 30.012, nominal length 30. So you come up with this plus 0.0324 meter. The temperature, because there were 3 temperatures, so you do it in segments. For L1 30 into alpha, and then 14 minus 20, plus then L2 again 100, but the temperature is of 15, and but our last segment is of 16. So for first segment was 30, that's why the length is 30, second is 30, and the remaining length was 21.15. We have to do it separately because they were different temperature. If we have a one constant temperature, you can do it. Sometimes all we can do is also take the average of 14, 15, 16, and you apply correction directly to 81.15 meter. But again, if you do it like this, there will be some error. So better to do it in segments. And now you don't require any segments because the pressure is same. So pull is same. That's why you have just applied it. Uh, it's simple, similar manner. I just forget to write L, that is 80.51 here, because this PT and P I know. Oh, sorry, the length is there, 30, 30, 21.15 meter is there. So actually there is no correction. Actually, this L is being taken in segments. Actually, you can take it 81.1151, but for the sake of understanding, I kept it like this. So you do never confused that all the segments are not being taken care of. Then there is, slope correction for sag. You know the weight, you know the slope length, and then this is just not slope length, the standard length, that is 30 meter, and then P1, the load, and you find this correction. At the end of all corrections, you accumulate them and you find actual distance is 81.131 meter, not 81.15 meter that you have recorded. So this is how, with correction, you get the actual length you measured with the tape. Now this is another example in which a steel tape of nominal length 30 meter was used to measure a line AB by suspending it between supports. The following measurements were recorded. The length measured 29.872 meter. Angle is 3 degree 40 minute. Mean temperature 5 degrees centigrade. Tension 120 Newton. And the standardization length uh, is 30.014 meter at 20 degrees centigrade at 50 Newton. The tape weighs 0.17 Newton per meter, and the cross-section area of 2 millimeter square calculated. Calculate the horizontal length of AB. This is the problem statement. Now you can do it similarly what we have done in the previous problem. Just one by one, temperature correction, C into delta T, then length correction, and then sag correction, the tape correction, and the slope correction. And at the end of a day, you will find your actual length is 29.823 meter. More, actually you measured 29.872, but it's not 29.872, actually it is 29.823 meter. These are just formulas, and this is uh, the repeat of the previous example with the difference that it has got a different units of measurement. So that's uh, with the tape. Now we go to another instrument, that's a subtense bar. It is a 2 meter rod, and whatever the distance is simply h is equal to cot alpha by 2 meter. So what you do, this is a rod openable end, you stretch it fully and you sight it from some telescope. There is aiming points and the aiming telescope, and you can see the distance. You sight this distance from point, and there is an alpha is always known to you. This h is also known to you, so you can find this distance length from the point like this. So this is the length of the bar, and this h is the distance between the point of interest, uh, the starting point, and obviously the end point or target. And this is simply, you know, this angle. So if it is say 30 degree, then alpha by 2 is 15 degree, and that's how you know actually L by 2, that's 1 meter, and then you you know alpha, so you can find h. So this is how you show tangent alpha by 2 is L by 2. These are all trivial things. You always know that how you come up with this horizontal cot alpha by 2. So this is a simple question. What is the distance between A and B? The angle alpha was 2 degree. Then odometer is a mechanical revolution counter. Is a wheel which uses an odometer to count the rotation like this. Gear ratio of odometer is usually designed to provide a measurement of distance in standard units, feet, decimal feet, and inches. Advantage, easy to use, low technology. Disadvantage, accuracy is influenced by surface conditions, must be able to traverse a distance, and only measuring slope distance. Error is 1% of the distance. So with this, I'll close my discussions, and from the next discussion, we'll use this optical distance measurement, and then probably, finally in the next lecture we'll finish this topic on horizontal distance measurement. Till then, take care.